Alright, you guys, in this video we're going to be discussing the topic of how to calculate the areas of shaded regions. Now, the first thing I want you guys to notice that when we're tackling these problems of areas of shaded regions is the shaded region is never going to be something pretty. It's not going to be something that, with our current toolbox equations for other shapes, we can just directly plug in chug numbers and solve for it. However, to combat that, what we can do is we can take the equations of areas of shapes that we already know, and what we can do is we can find a total area and just take pieces out, and that is going to allow us to solve these problems. Okay, so I'll show you what I mean by that with our first example. Let's say we have this shape. So let's pretend that the question is that they want us to solve for this red region inside of the box, okay? Now, upon first glance, as I said in the beginning, there's nothing pretty about solving for this area of the shaded region because there's no formula that we know off the top of our head that gives us ability to directly just plug in chug numbers and get the area. However, to combat that, what we can do is look very carefully at this and look for shapes and pieces that we are familiar with, that we can calculate the area of, to form a relationship with the shaded region and form our own expression. So when we first look at this, we can notice that the two shapes that we are familiar with, one being this rectangle, which we do know the area for, as well as not one, but two triangles, which kind of forms the bow tie looking kind of thing. And that's exactly how we can approach these problems. We can take a total area that we can solve for, and then we can just dissect out pieces. Okay. One of the ways that you can look at this is when you guys are having Thanksgiving dinner and you're going up to the line and you see one of your favorite dishes, like a casserole or something, and you take the spatula or whatever and you take out a piece. And what you notice is after you take out the piece, you probably go for the milk because it's the best part of the casserole, is you see that all that's left is, the casserole that's what you didn't take. And that's exactly how we can approach these problems. I mean, you're not going to get probably a bow tie shaped piece of casserole, but what we can do is we can take a total area, take out the pieces that we don't need for our shaded region, and calculate it. And that's exactly the expression that we can say. So we can say for this question that the area total minus the area of the two triangles, I'll call them triangle 1 and triangle 2. So area total minus triangle 1 minus triangle 2 equals the area of the shaded region, and I'll call that area SR. So let's do that. Okay, so let's first calculate the total area of this box. And this area of this rectangle is something we're familiar with, which is just base times height. So that's area is equal to base, which is 12 units, times height, which is 6 units, equals 72 units squared. Again, guys, remember, it's always going to be squared because you're taking a unit and multiplying it by itself, okay? So that's our area total. Now what we can do is we can take the area of the triangles. Now this may get a little tricky, but what I want you guys to notice is we're going to be solving for the area of a triangle, which is 1/2 times base times height. However, there are two triangles, so after we solve for this area, we have to add the same amount to get the area of the two triangles put together. Okay, I'll show you what I mean by that. So the area of a triangle is 1/2 times the base times the height. So we have 1/2 times the base, which is 2, times the height, which is 3, which is equal to 1/2 times 6. And again, guys, going back to the previous videos, I like to do the base times height first, because then all you're left is the half part times its product. So now you have 1/2 times 6, which is also equal to 6 divided by 2. Again, whatever makes you feel more comfortable in your calculations. So you're going to get 3 square units. Okay. Now, that's for one triangle. So to get the second triangle, we have to add on 3. And that gives us the total area of the yellow region, which is the two triangles. So now, going back to the creation of our expression, we can say that the area total, which we solved, was 72. The area of the triangle 1 minus triangle 2, or area of the triangle 1 plus triangle 2, is 6. And now, what we can do is a simple subtraction, again taking that piece of casserole out of the pan, and saying 72 minus 6 is equal to the shaded region. So the area of the shaded region is 72 minus 6, which equals 66 square units. Okay. Alright. Let's look at another one. And remember, guys, we can approach these questions all the same way. We can take the large area and just take out pieces. Alright, so let's look at this next one. Okay. Okay. And they want this area. Okay. Now, again, remember at first glance, this area that we're trying to solve for is nothing pretty. Okay, there's no direct plug and chug calculation formula that we have currently at our disposal in order to solve for that shaded region. But just like we did in the last example, we can just take out pieces and we can solve for it. Again, first thing we can do is analyze what shapes we can look at and that we know the area formula of, and then we can use them in a relationship to figure out how to solve for the area in question and form our own expression. So when we first glance at this one, we see that we have a trapezoid we also have a rectangle. Okay, now what we can do is we can say that if we solve for the area of the trapezoid, which will be the area total, okay, then we solve for the area of the rectangle, we can then say that the area of the shaded region is equal to the area total minus the area of the rectangle. So let's go ahead and do that. Okay. We have a trapezoid here, again, which we know the area for. Area of a trapezoid. Again, guys, remember a trapezoid is a quadrilateral with only one pair of parallel sides. Is equal to 1/2 base 1 plus base 2. Again, guys, remember with trapezoid area, doesn't matter which base you pick for base 1 or base 2, as long as you're consistent, times the height. So that's going to equal 1/2 6 plus 8, which is 14, times the height, which is 5. Okay, and when we do 14 times 5, we get 70. So we get 1/2 of 70 equals the area. This is yards. Remember, guys, keep your units. I'm not being very good about that right now, because you're going to get square units as your area. And remember, 1/2 times 70 is the same as 70 divided by 2, which is 35 square yards. Okay, so now we have that. Now let's calculate the area inside of the rectangle. And we know that the area of a rectangle is just base times height, which is going to be equal to 4 times 3. And that's going to be 12 yards squared. So now what we can do is take 35, which is our total area, and subtract off 12, and that will be our area of the shaded region. And to show that, again, remember, area of the shaded region is equal to area total minus area of the rectangle, and we're just going to take out that rectangle. So we have area total, which is 35, minus the area of the rectangle, which is 12, and we get 23, this is the total area, and this is equal to 23 yards squared. Okay, alright, you guys, I hope this video helps you out. If you guys have any kind of area associated region problems that you'd like to request, or if you have any questions regarding these, please let me know. Just remember again how to approach these. Just take the total area and extract pieces from it, just like that casserole, okay? I hope you guys have a good day. Thanks for watching. Bye.